scenario, you can still spoof the packets, and the output stream goes anywhere on the internet. This is still kind of an issue. So IPsec is a better solution. You can build an IPsec tunnel from the mediation device to the router, and that will encrypt not only your interception request going out, but all of the content coming back. Now, here's the problem. If you look at this network diagram, the interception request isn't coming from the mediation device, it's coming from another address. And so the router is not going to expect it to be encrypted. And the output stream is not going back to the mediation device, it's going to another destination on the internet, so the router is not going to encrypt that either. The only way that IPsec really protects you is if you couple it with that SNMP user group access list that I talked about. So that you only accept interception requests from the mediation device's IP, and you only accept traffic from that IP if it's IPsec encrypted. If you do both those things, this interface is pretty safe. So how practical is this attack? In the real world, what are people doing? I think that people are probably using that infrastructure access list that I talked about. I think some service providers might still be vulnerable to this bug from last summer because people don't upgrade their routers. It's just an operational risk, and so often people don't do it. There are many service providers that are not using encryption, and I don't think you can protect this interface adequately if you're not using encryption. And I don't think anyone's using that user group access list that I talked about. So in practice, this attack scenario is fairly practical. And I want to talk about another, has anyone ever attacked Lawful Intercept is a valid question to ask. This stuff never happens, right? So there's only one case that I know about where it's confirmed, it's not a rumor, that this really happened. It happened in Greece during the Summer Olympics that were there a few years ago. Someone installed some malware. This did not involve Cisco equipment. It involved an Ericsson cellular telephone switch. Somebody installed some malware, rootkit, in the phone switch. And these Ericsson engineers actually found this thing because they were auditing core dumps in order to troubleshoot a vulnerability. And they found assembly code in the binary that they didn't write. Can you imagine? And it turned out it was spying on people. This is like the technical support escalation nightmare from hell. But it turns out they were spying on like 100 senior members of the Greek government. They were spying on the Greek prime minister. What's really interesting about this, well, there's two things I want to say. The first is that these guys wrote malware that runs on a phone switch. This is really complicated. This is much more sophisticated than what I'm talking about, which is just generating an SNMP v3 request. Most of the people in this room could write software that generates an SNMP v3 request before this talk is over. So this is much more complicated. The second thing I want to point out about this is that if you go read this IEEE Spectrum article that discussed this, and you read between the lines, you see some of the same architectural components that exist in the Cisco architecture, where you've got this thing called the IMS, which is the intercept management system, where taps are provisioned, and that's where the audit trail is. And then on the other side, you have this thing called the RES, which is in the phone switch, which actually performs the intercepts. And what this malware did is it attached to the RES and got it to intercept. And they didn't mess with the IMS, so no audit trail was generated. So they've really used the exact same architecture, and they've removed the audit trails from the actual thing that performs the surveillance. And I think that that is a fundamental architectural flaw that affects a lot of Lawful Intercept implementations using different technology, because it all flows from that ETSI standard. So what should we do about all this? How should we address these vulnerabilities? I have recommendations for changes to the SNMP v3 standard that need to be made at the IETF level. I have recommendations for Cisco for how they can change their specific implementation. And I also have recommendations for ISPs that are using this today that need to deploy it safely. And so one of the questions that gets asked is, if this can be deployed safely by an ISP today, why change the protocol? And I had a bunch of slides that are on the CD that relate to this, and I decided to pull them for timing reasons. And because in this room I'm kind of preaching to the choir, you guys get this, but a lot of people that design protocols don't get it. I think that protocols ought to be designed with the anticipation that people will not deploy them in an optimal way. We know we could deploy it in a secure way, but some people won't do that. And so we should design protocols that fail gracefully when they are not deployed properly. And so I think that changes are warranted here to make the things a little bit more secure if the provider didn't do all the right things. So what are my recommendations for SNMP v3? I think that we should make authentication errors less helpful to attackers. Don't tell them why something failed to authenticate, just tell them to go away. At the same time, I think we need to make authentication failures more helpful to network administrators. Instead of telling the attacker why we threw his packet out, we should tell the network administrator that the router's under attack. Furthermore, I think that the engine values should be more difficult to predict and share. This isn't really a flaw, it's just an unanticipated possibility that they didn't consider. They designed these engine values to prevent replay, and they prevent replay well, but they almost prevent spoofing. And if they were improved by making them more similar to SYN cookies, they would effectively prevent spoofing. What you want to do is include the source address that the request came from and a secret, and produce a number that's unpredictable and send it back. And then they can't share it. I can't go collect that number and then use it in a request that I'm spoofing from another address. I think that change could be made without a flag day for SNMP v3. I think that routers could simply start sending out more complicated engine times, and everything would just work. Recommendations for Lawful Intercept. So one of my recommendations is to use a different port. And actually, I should have clarified something earlier. All these recommendations I'm making are from my perspective as a security researcher. I acknowledge that I don't know everything that goes on in the world. I don't know all of the design criteria that were used in designing some of this stuff and all of the reasons why it's designed the way it's designed. And so I accept that some of my recommendations might not be recommendations that can be taken. I'm providing a number of different options, and some of them will work and some of them won't. And anyway, use a different port. There's a lot of SNMP traffic going on a provider's network that's used for all kinds of different purposes. If you move Lawful Intercept to a different port, it's easy to make access lists that filter it specifically instead of general access lists that say everyone who does SNMP can come in and talk to this service. The router administrator should be able to limit the destinations for the output stream. You should not be able to send your content to Botswana over port 53. The router administrator should be able to specify an access list that says this is where you can send content. They should also move notification control into the router configuration. And this goes back to that fundamental architectural flaw that I was talking about, where they don't want the router administrator to be able to notify his buddies when the wiretapping is being performed. So the way to deal with that is to design this so that you get agreement between the router configuration and the interception request. So the router administrator specifies a list of addresses that traps can be sent to. Okay, and then when the mediation device generates the interception request, it specifies an address to send traps to. The router enforces that the interception request specified an address, and then that address is one of the addresses that the router administrator also specified. So in this case, the person generating the interception request must include an address for notification, and that address must be one that the network administrator has agreed to. But conversely, the person who configured the router, cannot send intercept notifications anywhere that the people who run the mediation device haven't agreed to. Nobody can fool around. I think that effectively solves the security concerns involved in the audit trail without eliminating the audit trail entirely, which is what has been done in a lot of these systems. I also have recommendations for proper deployment that came out of this research. First of all, make sure you've patched that SNMP bug. I know it's a pain to patch your router, but it's important when there's a serious security issue. Use encryption, specifically IPsec. If you're not encrypting, then there's no way that you can protect the content coming back. And really, there's no way that you can prevent this interface from being used without authorization. Use the user group IP access control list that I talked about to lock the SNMP user for Lawful Intercept down to the IP address of the mediation device. If you do those three things, this interface is pretty safe. If you're not doing them, then there is a risk that it could be used without authorization. Furthermore, there's all kinds of other things you need to do to run a secure router network, and that discussion is way outside the scope of this talk, obviously. But one of the things you might consider is building out-of-band management networks so that your management traffic is going over a different interface into these routers than the traffic that is part of the network itself. It's expensive to do that. Some providers do it. I think it makes a lot